Hello, in this lecture we are going to start with the differentiability of functions. We have done till now continuity as well as differentiability, and today is the day. Then we are going to start. We are going to go ahead as far as our journey of differentiability is concerned. Okay, so we have done till now uh, a few concepts like we have done. Okay, just give me a minute, and I hope. Let me just share you the screen. Okay, just give me a minute. I hope. Uh, okay, so let us start with differentiability, and I hope now the screen must be visible to you, and I'll just let you know what we have done till now. So we have done till now a few things, like we have done continuity till now. Okay, then we started with differentiability, and then we saw some properties for the differential functions. We also saw that if my function is continuous, then it not necessarily implies that my function is if my function is continuous, then it need not necessarily imply that function is differentiable. But if function is differentiable, then it is essential for it to be continuous. Okay, so for example, if I say that my function is continuous, if my function is differentiable at a point, then it would be continuous at that particular point itself. So uh, these are the things that one needs to remember, and I'm waiting for people to join in, and once they join, they will start. Okay, so let us start with the differentiability of functions. We have done till now continuity, and we were actually doing some properties of the differential function in the previous lecture, and we also saw inverse function theorem. And today I'm going to do a few questions for you, and also I'm going to see okay, I'm going to see a few more I'm going to teach you a few more concepts as well. So let us move ahead with this. Okay, so okay, so let us move ahead with this. Okay, what can be said about this particular function? Let f be defined from R to R be a differentiable function. Be a differential function. Sorry, not be a function defined by fx equals to x square sine 1 upon x not equal to 0, and whenever x equal to 0, it is equal to 0. Now we want to see whether the function is differentiable. Is fx differentiable at x equal to 0, and if so, what is the value of the derivative? What is the value of the derivative? We have want to find this. So let f r to r be a differential function, and it is defined as x square into sine 1 by x whenever x is not equal to 0, and whenever x equal to 0 it is equal to 0. Then question asked us, is fx differentiable at x equal to 0 or not, and if so, what is the derivative of the function at 0? Okay, so then what is the derivative of the function? So you would see that we want to find whether my function is differentiable. So I'll take the limit x tends to 0, f of x minus f of 0 minus x minus 0, and which will lead to you x tends to 0, f of x is simply x square sine 1 upon x divided by x, and it will give you limit x tends to 0 sine of 1 upon x. Now remember, whenever x tends to 0, 1 upon x would tend to infinity, and sine 1 upon x would invariably jump from minus 1 to plus 1. That it will oscillate between minus 1 to plus 1. So sine 1 by x will oscillate between minus 1 and 1 very rapidly. Very rapidly. That is, if I want to just show you how the function would behave, so your function would be actually towards tending to 0, it will be like taking good amount of oscillations in the neighborhood of x equal to 0. So in the neighborhood of x equal to 0, if you want to write, I can write that sine 1 upon x will be some oscillating number. It will be some oscillating number between minus 1 and plus 1. Okay, so it will be some oscillating number between minus 1 and plus 1. And if you see, this will be some oscillating number between minus 1 and plus 1, and what it is being multiplied to, it is multiplied with x, which is tending to 0. So all this quantity would go to 0. It implies that indeed f dash x is differentiable at x equal to 0, and further the limiting value is coming out to be equal to 0, so that implies f dash 0 is equal to simply 0. Is that clear? Kindly let me know in the comment section if you are getting it, then please let me know so that I will move ahead, and if you are not following it, let me know. Is that clear? Kindly let me know on the chat box so that I'll move ahead then. Okay, so let us move ahead and see. You have to see the differentiability. Check the differentiability of function f of x given by simply x times greatest integer x minus 1, where x lies between 0 and 2, and whenever x lies between 2 and 3, it is simply equals to greatest integer x into x minus 1. We have to check the function of we have to check the differentiability of this particular function. Okay, so how to check the differentiability of function? See, at times even graph can help you. Okay, so you know that whenever your x lies between 0 and 1, that implies your x minus 1 will lie between minus 1 and 0. In that particular case, I can write that my greatest integer x minus 1 would be simply minus of 1. Now if your x lies between 1 and 2, then clearly x minus 1 lies between 0 and 1. So your greatest integer x minus 1 is simply equal to what? 0. Okay. Similarly, whenever x lies between 2 and 3, your greatest integer x would be 2. So basically, the function that has been given to you can be rewritten in this form. So I can rewrite this particular function as simply minus of x whenever x lies between 0 and 1. Whenever x lies between 1 and 2, it is simply equals to what? 0. And whenever x lies between 2 and 3, it is simply 2 times x minus 1. Okay, so if I want to plot the graph, you'll see that this particular graph will be, see how it will behave. See, so whenever your x lies between 0 and 1, it will be simply minus of x. So I'll make the graph here. So minus x means from here to here, from 0 to 1, it will be minus of x. Exactly x equal to 1, it will be 0. From 1 to 2, it will remain 0. So let me darken it. At exact x equal to 2, it will again jump to another function which is equals to 2 times x minus 1. So this will be 2 times x minus 1. This is simply 0 here, and it is simply minus of x. So you can see clearly fx is discontinuous at x equal to 1. Clearly it is the case. You can see the function is discontinuous at x equal to 0 and also at x equals to 2. Therefore, the function will be non-differentiable as well. So always remember that if function is non-discontinuous, then it is non-differentiable as well. Then fx is, therefore fx is okay at x equal to 1 and x equal to 2 as well. Okay, so this is also one of the ways in which you can do the questions. I hope it is clear. Now check the differentiability of the function. Check the differentiability of the function f of x equals to x e to the power of minus of 1 divided by modulus of x plus 1 upon x whenever x is not equal to 0, and whenever x was equal to 0, it was equals to what? It was equal to 0. Then we have to discuss the continuity and differentiability of function f of x at x equal to 0. We have to find we have to find the continuity as well as differentiability of the function f of x at x equal to 0. So how to find this thing? So how to do it? So let us first check how the function can be defined. So can function be redefined? Yes, it can be indeed redefined, because see, for all x less than 0, 1 upon modulus of x will be minus 1 upon x. It is minus 1 upon x, and this is plus upon, it will be 0, so it will be simply x. At x equal to 0, it will be simply 0, and at x greater than 0, it will be simply x into e to the power minus of 2 by x. I hope it is clear. Now you see, if I want to find the differentiability at to the right of 0, what you will get? You will simply get limit h tends to 0 f of 0 plus h minus f of 0 divided by h, and what you will get? You will simply get h into e to the power of minus 2 upon h minus 0 divided by h, and this, from this you will get simply 0, because as h tends to 0, this will tend towards infinity, and e to the power minus tending to infinity quantity will obviously go towards 0. I hope it is clear. And if you want to find the left hand derivative at x equal to 0, you will get limit h tends to 0 f of 0 minus h minus f of 0 divided by simply h, and it will be equals to minus of h minus 0 divided by h, and it will be equals to minus 1. So clearly the right hand derivative is not equal to the left hand derivative at x equal to 0. So therefore one can clearly assert that my function is non-differentiable. F is non-differentiable at x equal to 0. I hope it is clear. I hope it is clear, Harshit. Should I go ahead? Okay, so now let us do a question from your JEE exam only, and this is an important question. Let us see if you can just get what the question is saying. This was asked in JEE exam of 2004, I guess, and it was one of the very toughest papers in the decade. Like in from 2000 to 2010, it was the toughest paper. Look, my seniors used to say that. That is what I'm saying. So let if f belong if f is defined from minus 1 comma 1 to r, and f dash 0 is simply equals to limit n tends to infinity n into f of 1 upon n, and f of 0 is equal to 0, then we have to find the value of limit n tends to infinity, and then you have 2 over pi, and then you have n plus 1 into cos inverse 1 upon n minus n, given that limiting value n tends to infinity cos inverse of 1 upon n mod always lies between 0 and pi by 2. Okay, so this is how it is. Okay, so one wants to find, see, f dash 0 is simply limit n tends to infinity n f of 1 by n, and f0 is equal to 0. So that was indeed the case also. See, Harshit, is that clear? Just let me know in the comment section. So let us do this problem. In this problem, you see f is defined from minus 1 comma 1 to r, and f dash 0. So f dash 0 is what? F dash 0 is simply given to be equals to limit n tends to infinity. Even if this was not given, then also you can see, after all, this 1 upon n as n tends to infinity, isn't it that 1 upon n would tend towards 0? So can I not write 1 upon n as simply h? Okay, so basically it is and 0 is simply given to be 0 divided by n, it used to be, so I'll write it as 1 upon n here. So clearly one can see that this particular form, that is f dash 0, is nothing but it is equals to limit n tends to infinity n into f of 1 upon n. Is that clear or not clear? Now you see, question given to you is that find the value of this particular limit, that is limit n tends to infinity 2 by pi n plus 1 cos inverse 1 upon n minus n. We have to find the value of this particular function. You see what I can do, I will simply take n comma naught from here. So what I'll get, limit n tends to infinity, if I take n comma naught, what I'll get, I will simply get 2 upon pi 1 plus 1 upon n into cos inverse 1 upon n minus of 1. This is what I want to find. And see, after all, if I just compare, if I just compare what it is, see what is happening. I can see that this particular thing, if I write it as simply function of 1 upon n, if I write it as simply f of 1 upon n, so then limit n tends to infinity n into f of 1 upon n is simply what? Is simply f dash 0. Okay, see here it was given. So if I take an n common out, then the remaining part, if it behaves as if it is a function of 1 over n, which indeed you can see here. So n into f of 1 upon n limiting value n tends to infinity, this particular thing is equivalent to f dash 0. This particular thing is equivalent to f dash 0. So you can see this particular thing would actually mean what? It means what? It means you are saying that your f of x would have been 2 upon pi 1 plus x cos inverse of x minus 1 only, because you see instead of this only you have placed 1 upon n and only then you have written in this form. So basically what is happening, this is your f of x, this is your f of x, and what you want to find is you want to find this particular expression. So basically what does it mean? It means that you want to find f dash 0. You want to find f dash 0, right? See again, I'm coming back to the question. See how the question was given to you. The question was given to you in quite disguise. It was given that f is defined from minus 1 comma 1 to r, and f dash 0 was given as limit n tends to infinity n into f of 1 by n, such that f of 0 is equal to 0. Okay, now you understand what is f of 0. F dash 0, what is f dash 0? It is simply n tends to infinity n into f of 1 by n. That you can also see from this particular expression that it is right. Why it is right? Because see, if I want to write what is f dash 0, what is f dash 0? F dash 0 would be limit h tends to 0. It will be simply limit h tends to 0, f of 0 plus h minus f of 0 divided by h. And instead of h I have written 1 upon n and I have taken n tends to infinity. So whether you, even if it was not given in the exam, you can understand that f dash 0 is equal to this. Now understand, we have to find the limit of this particular thing. So we have to find the limit of this particular thing. So how to find the limit? So what I have done, I have just taken an n comma naught from here. So I have taken an n comma naught from here. So if I take an n comma naught from here, what is happening? It is behaving as if it is n into f of 1 upon n. And I know that n tends to infinity, n into f of 1 upon n is nothing but f dash 0. And from this particular structure, I have come to understand that this particular thing which I have marked in purple in arrows between the arrow, this is nothing but this is f of 1 by n. So what would have been the structure of f of x? The structure of f of x would have been f of x equals to 2 by pi 1 plus x into cos inverse of x minus 1. This would have been your f of x. And if I know what is f of x, I will be able to find what is f dash 0. So what would be f dash 0? F dash 0 would be simply 2 upon pi cos inverse of x plus 2 upon pi 1 plus x into minus 1 upon root over 1 minus x square, and all these things I have to evaluate at x equal to 0. And if I evaluate all these things at x equal to 0, I will get the value of f dash 0 as simply 2 upon pi into cos inverse 0 is pi by 2, then plus this will give you 2 by pi, and this is I think 1, then minus 1, so I'll get minus 1 here. So effectively I'll get an answer as 1 minus 2 upon pi. I hope it is clear. Please let me know in the comment section if you've followed it. Is that clear or not clear? Now you see, let us move further and see a few more things regarding differentiability. See, now one important question, if you'll find this particular question is quite important for you for your examination also. See, I okay, so this particular question I'm discussing now. So let R be the set of real numbers, and let f be defined from R to R be such that for all x and y in R, fx minus fy modulus is always less than equal to mod of x minus y ka whole square. Then we have to prove that f of x is constant. How to go about it? See, it has been given that a function f is such that it is defined from R to R, and f of x minus f of y ka mod is less than equal to x minus y ka whole square. So what I'll do, and let f be a function which is differentiable. Okay, just take that function is differentiable. So if your function is differentiable, then you see, limit, if I want to take limit x tends to y, this will be f of x minus f of y. What I'll do, I'll take one modulus here, modulus x minus y down. Is that clear? So you'll get this. What does it imply? And here x and y are any arbitrary real number. Understand the point that x and y can be any arbitrary number. So I've taken limit value x tends to y. So if I take x tends to y, this will give me simply f dash y mod will be less than equal to 0. Can any quantity's modulus be less than 0? Can it be possible that if I am taking a modulus of any quantity which is real, can it happen so that the derivative, that the modulus of a derivative is less than 0? No. So it implies what? It clearly implies that your f dash y must be equal to what? 0. And if your f dash y is equal to 0, that implies your fy is a constant. And here you understand, here we did not take any specific value x and y. This is true for any arbitrary value of y. So for all y belongs to R, if I'm saying that fy is a constant, it implies that fx is a constant function. Is that clear or not clear? Or should I repeat it? If you have not got it, then you can also take this way. See, this particular statement that fx minus fy mod is less than equal to mod of x minus y ka whole square. This particular statement is true for all x y belongs to R, isn't it? Okay, so it will be true for what? It will be obviously true for it, since it is true for any x y belongs to R, it will be true for, let's say, y is equal to x plus h and y is equal to x minus h. Why I'm saying this is, see, if x belongs to R, then x plus h also belongs to R. If you choose any x arbitrarily, then x plus h would also be an arbitrary thing. So basically y would also become an arbitrary value. So if I take all x belongs to R, so x plus h you take or x minus h you take, all these things will obviously will also be some arbitrary real number. This will also come from some arbitrary real number. So if I say that what would be the value of limit h tends to 0, f of x minus f of x plus h divided by, if I take this one of them below, like if I take here, it is x minus y into x minus y, right? So if I take one x minus y below, so there would remain some x minus y there. So it will be simply h there. Now you take h tends to 0. So if I take h tends to 0, this will go to 0. After all, you are left with the right hand derivative, or even if you take the left, if you write x minus h, you will get the left hand derivative. In short, you will get this thing: f dash x ka mod is less than equal to 0. Can any quantity whose modulus values is on the left hand side, can it be this particular quantity be less than 0? No. So that implies your f dash x has to be equal to what? 0. It implies fx is a constant function. Remember, this is an important question. Is that clear now? Or should I repeat it again? Is that clear? Should I repeat it? Okay, chalo. Chalo. So let us move to another question, and now we'll do some questions on. We'll do some questions from JEE examinations. Okay. So now we are coming to the most important thing, that is our exam. Okay. So the first question that comes here for you is, let's say your f of x is defined as f of x is simply defined as x times sine of pi x greatest integer. Then we have to see that whether your fx is continuous at x equal to 0, whether it is continuous at x belongs to minus 1 comma 0, whether it is differentiable at x equal to 1, or it is differentiable in minus 1 comma 1. So we have to see in which of the following statement is correct. Okay, so whether it is continuous at x equal to 0, option number 1. Then option number 2 is whether it is continuous at x equal to minus 1 comma 0, whether it is differentiable at x equal to 1, or whether it is differentiable at minus 1 comma 1. This is what we have to see. So how will I proceed? So let us first check continuity. So if your function is discontinuous at a point, then certainly it is going to be non-differentiable at that particular point. So that is very much clear. That is very much clear that if at a point, if I know that my function is non-differentiable, if at a point I know that my function is discontinuous, then at that point my function would be non-differentiable as well. So you see, let us start from here. This is the biggest interval. So here, if your x lies between minus 1 and plus 1, so if x lies between minus 1 and plus 1, okay, just give me a minute. Okay, so if x lies between minus 1 and plus 1, what will happen? So I'll take the cases where your x is an integer. I'll do that. But first I'm doing that if my x lies between, so it implies what? My pi x would lie between where to where? My pi x would lie between minus pi to plus pi. Okay, and if that is the case, I would write that my sine pi x would lie between I think minus 1 to plus 1, right? Because what is minus pi to plus pi? Let's say this is your pi. This was your pi. Then what is minus pi? Minus pi would be this. So basically, if I'm saying that my x is derived from minus pi to plus pi, so it will cover the entire 360 degrees. Is that clear? What is minus pi? Minus pi is actually approaching the angle from the downwards. And what is 0 to pi? So from 0 to pi, it will cover all the upper quadrant, and minus pi to 0, it will cover all the lower quadrant. So my sine pi x would lie between -1 and +1. Is that clear or not clear? And if I multiply x into sine pi x, see, sine pi x in any on any date will depend. It will always lie between -1 and +1. Okay, it will lie between -1 and +1. This is very much sure. And what is the and x is also lying between -1 and +1. This is very much clear. So what does it mean? It means in any case my function x into sine pi x. So for example, let us take two cases. One of the cases would be this. Let us say that when my x lies between minus pi and 0. That is, sorry, my pi x lies between when pi x lies between minus pi to 0. Because see, here there are two cases now. Your pi x is lying between minus pi to plus pi. That is, it is lying between minus pi to 0 and then from 0 to pi. From minus pi to 0, 1, and from 0 to pi another. So if your pi x lies between minus pi to 0, your sine would lie between -1 to 0. That is sine with the sine pi x I'm referring to. And if you multiply it with x, x itself is negative. X itself is negative. That is, x here varies from where to where? X here varies from -1 to 0. Only then your pi x would have been from minus pi to 0. Are you getting my point or not getting my point? What I'm trying to say, that if I'm considering the lower half, if I consider the lower half, in this lower half you can see that your x varies from -1 to 0, and as a resultant your pi x varies from minus pi to 0. Since your pi x varies from minus pi to 0, the sine pi x would vary from where to where? From -1 to 0. This is clear. And if I multiply it with x, which itself is negative, however this negative is also lying, this x being negative also lies between -1 and 1 only. So overall this particular term x into sine pi x would always lie between 0 and 1 only. Would always lie between 0 and 1 only. This is very much clear, that this x into sine pi of x would lie between 0 and 1 only. If I now consider the upper half, on the upper half I will say that if my x lies between 0 and 1, then my pi x would lie between 0 and pi. And if pi x lies between 0 and pi, what does it mean? It means that your upper half is being considered. If upper half is being considered, sine pi x would lie between what to what? It will lie between 0 and 1 only. If sine pi x lies between 0 and 1, when this sine pi x is multiplied with x and x lies between 0 and 1, overall x into sine pi x will again lie between 0 and 1 only. Okay, you take any quantities from 0 and 1, and again you take any quantity from 0 and 1, you multiply them up, you will get the value in 0 and 1 only. So in any case, if I write what will be the greatest integer value of x into sine pi x, it would simply be clearly equal to 0 whenever x lies between what? Whenever x lies between -1 and 1. Is that clear? Is that clear? I hope, Harshit, is that clear? I mean, see, understand my point. Yeah, good. So good enough. So point is this: what I wanted to suggest was that if my x is lying between -1 and 0, my pi x would lie between minus pi and 0, and if my x lies between 0 and 1, so my pi x would lie between 0 and pi. So while I go from minus 1 to plus 1, while my x goes from minus 1 to plus 1, my pi x would actually cover the entire 0 to 360 degrees, that is 0 to 2 pi. Point number 1. Point number 2 is, what about sine pi x? So on the upper half, that is on the first two quadrant, your sine pi x would lie between minus 1 and 1, and on the lower half, your sine pi x would again lie between minus 1 and 1. Now if you see, if you take the lower half, sine pi x is already lying between minus 1 and 1. In lower half, your x lies between minus 1 and 1. You multiply them up, so you will get that x into sine pi x would be something between 0 and 1. And if you take a greatest integer, so that is what has been asked. If you take a greatest integer, this particular thing would become 0. So that is very much clear that the given function to you, that is f of x, equivalent to greatest integer x into sine of pi x, this will be equal to 0 whenever x lies between minus 1 and 1. Now, what about x equal to 1? If you take x equal to 1, sine pi is 0. And what if x equal to minus 1, sine minus pi is also 0? So for all x belongs to minus 1 comma 1 inclusive, your x into sine pi x greatest integer is 0. Now see basically what is happening. Your function would behave like this way. From minus 1 to plus 1, your sine x into sine pi x is simply 0. Oh, sorry, my mistake. It is simply 0. Okay, it is simply 0. Is that clear, Harshit? I hope it is clear. Your f of x is simply equal to 0. Now your function is a constant. If I'm talking about a constant function, is it not continuous at x equal to 0? It is clearly continuous at x equal to 0. Whether you go towards the left hand of the 0 or whether you go to the right hand of the 0, sorry, just the other way around. Whether you go to the right hand of the 0 or whether you go to the left hand of the 0, fx is assuming 0 only. So clearly fx is continuous at x equal to 0. Good enough. Whether it is continuous between minus 1 and 0, yes indeed it is. From minus 1 to 0, again it is bearing a constant value, and a constant function is a continuous function. So second also is correct. Whether it is differentiable at x equal to 0, so whenever you are told such options, whenever you are given such options, you will have to see that. I'll have to see that whether it is differential between minus 1 and 1. Yes indeed, because it is given not open, it is not closed, it is given open. So in the open interval from minus 1 to plus 1, in the open interval minus 1 to plus 1, fx is a constant. If fx is a constant, then it is a differential function. Why did I stop here? I'll let you know. So what happens is, whenever you have a closed interval, let's say a comma b, and you have to see whether your function is differentiable at a or b, then what needs to be done? You need to see what is the value of the derivative to the right hand of a. Okay, at exactly a, if I want to find exactly at a, if I want to find what is the value of the derivative, then I have to find to the right of a, and if I have to find what is the value at b, then I can only afford to find the left hand derivative at x equal to b, because to the right your function is not, the domain is not allowing you to lie there. Is that clear? Because your function is defined from closed interval a comma b only, na? Is that clear or not clear? Or should I repeat it all over again? Acha, halaki function to is defined everywhere. So if you want to see, okay, that will also do. So see, we had defined our function f of x as x into sine pi x greatest integer, and we were seeing it only between x lies between minus 1 and 1, right? Now we have to see whether my function is differentiable. Okay, sorry, I thought function was defined between minus 1 and 1. Rather, it is not the case. It is asking for everything. So if function is differentiable at x equal to 1, then left hand derivative should exist and right hand derivative should also exist, and it should be equal to 0. Okay, then both left hand as well as right hand derivative must exist and they must be equal to 0, isn't it? Now let us first find what is the right hand derivative, and then we'll find what is the left hand derivative. So understand, I thought this is a closed interval. Rather, it is not a closed interval. It was you were just given a function f of x equal to simply, I think it was given f of x equal to greatest integer of x into sine pi x, and there was no such domain given to you. So don't worry about it. Actually, I thought it has been given to you. No. However, the options were suggesting, that is why we took this particular value. However, always remember, if you are given a closed interval a to b, and if somebody asks what is the value of the derivative at a, then you are supposed to find the right hand derivative, and if you are told to find the derivative at b, you are supposed to find the left hand derivative clearly. Okay, that indeed is the case. So now let me check it. Okay, so what will happen is, let me check the right hand derivative. So how would right hand derivative behave? So I'll write limit h tends to 0, 1 plus h sine pi plus pi h. Okay, sine pi plus pi h minus 1 into sine pi greatest integer. Here also you'll get a greatest integer, and then divided by 1 plus h. So what? So if I want to find the right hand derivative at x equal to 1, then what will be the value? I'll write it here so that you don't get confused. Limit h tends to 0, f of 1 plus h minus f of 1 divided by h, divided by h, and limit h tends to 0. This is what is your right hand derivative. This is what is your right hand derivative. So if I want to find the right hand derivative, this will be the case. What is sine pi plus pi h? It will be minus sine of pi h, and it is multiplied by 1 plus h minus 0 divided by h, and this is greatest integer, don't forget. Now remember, 1 plus h tends to 0, this will be simply 1 only, and what this particular thing would be, be it anything, sine pi h divided by h, and this is greatest integer, don't forget, this is simply greatest integer. This is simply greatest integer. You see, or you want to write it in this fashion, then also you can write this this way. See, h tends to 0, and this is 1 plus h. So basically, it will behave as if it is minus sine pi h, and h is not exactly equal to 0. It is rather tending to 0. So how would sine pi h behave? Sine pi h would be some value which will be lying between 0, close to 0, but less than 1. And if you take a negative of it, and if you take a greatest integer, you will get minus 1 upon h, and this will be tending towards minus infinity. Is that clear, Arshad? It will tend towards minus infinity. And if you want to find what will be the left hand derivative, limit h tends to 0, if you want to find the left hand derivative, it will be simply 1 minus h into sine pi minus pi h, which will be simply sine pi h minus 0 divided by h, and this whole greatest integer. Just understand, this sine pi h would be some value which will lie between 0 and 1. This lies between 0 and 1, and it is multiplied with the quantity which is slightly less than 1. If you have a quantity which is actually slightly less than 1 and you want to find the greatest integer, it will be 0 minus 0 divided by h, it will be simply 0. So clearly your right hand derivative is not equal to left hand derivative, therefore your function will not be set as a differential function at x equal to 1. Is that clear or not clear, Arshad? See another question on inverse function theorem. You see, question was given, if G is inverse of f, if G is inverse of f, and f dash x is simply given to be equals to 1 upon 1 plus x ki power 5, then g dash x is equal to what? It is asked in the exam. Then g dash x is equal to what? So let me just do it for you. See, I taught you on the very first day, whenever such questions are asked, you just apply the inverse function theorem. If you can remember that particular theorem, that is fine. Otherwise, just remember, if I am going to compose my inverse of a function with my inverse, with my original function, I will simply get x. Is that clear? Now, if I differentiate it, what I'll get? I'll get f dash, f inverse, fx, this whole dash, times f dash x is equal to 1. Is that clear? And what I will get? I will simply get this. See, what is f inverse? F inverse is g, so I'll write g f of x dash is simply 1 upon f dash x. Okay, is that clear? Should I write it in the form of g only so that you are going to get it? Okay, if you're getting confused, then let me just write it for you so that you don't get confused. So what I wanted to say, if g is given to be f inverse x now, if g is given to be f inverse x, so what I'll do, actually, I think there's a confusion. So if there is confusion, see, this is what I'm trying to say. So if g is your inverse, if g is your inverse, acha, we want to find g dash x now. एक काम करो, let us take, sorry, let us take एक काम करते हैं, let us take f of g of x. It will be simply x. Why it will be simply x? Because you see, if you are going to compose your function with its inverse, then it will be simply x, isn't it? Sorry, actually I thought we want to find g dash x now, so we'll use this. See, what is the problem with g of f? The problem with g of f is, if you are going to differentiate it, you will get g dash fx, and then you will be again in fix, because now you want to know how your function is defined, and that is not known to you. Your derivative is known rather. So what I'll do, I'll simply go with this particular thing. I will write that my f of gx would be simply equals to x. Differentiated, what I'll get f dash gx into g dash x equals to 1. Okay, and if I write this up, I know my f dash x is simply 1 upon 1 plus x e power 5, so I'll get 1 upon 1 plus gx whole raised to power 5 is equal to 1 upon g dash x. What is g dash x? That is what needs to be found. Sorry, I'll write it again. So my g dash x would simply be equals to what? It will be simply 1 plus gx raised to power 5. This was given in the option, so this is the correct answer. Is that clear? Harshit, is that clear? One more question before I leave, and then we'll take the class tomorrow, probably day after. I'll take a binomial theorem class, okay? So that will be good. Again, a question from J only I'm taking. If I'm given h of x as minimum of x comma x square, then we want to know how and where the function is continuous and differentiable. Where the function is continuous and differentiable. You want to find where the function is continuous and differentiable. So how to find this particular thing? See, if your function h of x is given as minimum of x comma x square, understand one point, that whenever your x lies between 0 and 1, whenever x lies between 0 and 1, always remember x square is very less than x. You can take it as, take one example. Let's say x equals to half. If you take x equal to half, clearly x square will become 1 upon 4. You take x equal to 1 upon 10, your x square will become 1 upon 100, and so on and so forth. So one can clearly see that if I take x between 0 and 1, then x square will always be less than x only. Will always be less than x only. Now, if x is greater than 1, then obviously x square would be on any day greater than x1. If x is greater than 1, then x square will always be greater than 1. Also remember that if x is negative, then in any case x square will always be greater than x, because after all x square will always be positive. So if I want to make the graph of minimum of x comma x square, I will have to take three kinds of considerations. The first consideration is, what about x lying between minus infinity to 0? So if your x lies between minus infinity to 0, then the minimum is simply x. So between x square and x, you can clearly see that x is minimum. X square is greater than x. Okay. When x lies between 0 and 1, when x lies between 0 and 1, then x square is minimum. So how is x square made? Had it been complete, then complete parabola would have become. Now right now you cannot say, you will have to put a parabola from 0 to 1. And if x is greater than 1, then again it will be simply 1. So from the graph you can see that there are 3 points where a probability is that your slope is changing. Here you can see that your slope is changing. Here you can see that your slope is changing. So these two critical points need to be seen. Otherwise it is all fine. You can see that for all x greater than 1, it is simply x. What is x? X is a linear function. Linear function is continuous as well as differentiable. For all x less than 0, again it is x. X is a linear function. It is continuous as well as differentiable. What about this particular function? What about this particular function? So here it is x square. From 0 to 1, it is simply x square. Now one needs to find the continuity and differentiability at x equal to 0 and x equal to 1. It seems that these are the critical points that one needs to evaluate. Okay. So if I will evaluate these points, limit x tends to 0, f of x, if I want to evaluate, what it should be equal to f of 0 if it is continuous at x equal to 0. What is f of 0? F of 0 is simply 0. And if you take 0 minus h, what is 0 minus h? F of 0 minus h is simply minus h, because to the left of 0, function is behaving linearly, the value would come out as 0. If you see towards the right, f of 0 plus h, if you want to see, it will come out as simply h square, again it is 0. So exactly at x equal to 0, you can see that your function f of x is continuous. Clearly fx is continuous at x equal to 0. Okay. Now what about x equal to 1? What to say about the derivative? So you can instantly see from your graph only, to the left hand side of x equal to 0, the graph is fx equal to x. The derivative would simply be equals to what? 1. Yeah, 1. Because fx is equal to x, the derivative of x is simply 1. And to the left hand side of x equal to 0, the derivative will be the derivative of 2x square, which is 2x at x equal to 0. This you will get simply 0. So clearly the left hand derivative is not equal to the right hand derivative. So therefore I can say that at x equal to 0, the function f is not differentiable. If you want to do it in the manner that we did earlier also, that you can also do. For that again you have to take a limit. So if I want to take the limit, to the left it will be f of 0 minus h minus f of 0 divided by minus of h, and this you will get f of 0 minus h. What is f of 0 minus h? This is simply minus of h minus f of 0 is simply 0 divided by minus h, so you will simply get it as 1. If you want to write to the right hand side, it will be f of 0 plus h minus f of 0 divided by simply h. It will be equals to h square minus 0 divided by h. You will get simply h is simply 0. So the derivative to the right hand of 0 will be 0. Derivative to the left hand of 0 would be equals to 1. So clearly the right hand derivative is not equal to left hand derivative. So therefore I can assert that at x equal to 0, your function however is continuous but not differentiable. Remember, continuity does not imply differentiability. Differentiability implies continuity. However, you can say that if a function is discontinuous at a point, then it is going to be non-differentiable at that point. So if a function is discontinuous, you can straightway reject the differentiability at that particular point. So if a function is discontinuous at a point, then it is surely going to be non-differentiable at that particular point. Now you have to check, what about x equal to 1? What about x equal to 1? So to the right hand side of x equal to 1, your function is simply what? Your function is simply x. The derivative of x is simply 1. And to the left hand side of x, your function is simply x square, so it will be simply twice x, or I can write 2 times 1 minus of h, and it will be simply 2. Clearly your right hand derivative is not equal to left hand derivative, so therefore function is non-differentiable at x equal to 1 as well. Is that clear, Harshit? So clearly I can say that my function is non-differentiable at 2 points, that is x equal to 0 and x equal to 1. At all other points it is differentiable and in fact continuous as well. So I hope today's class you've got a lot of things. Tomorrow we are going to continue with uh, probably tomorrow or day after we are going to continue with the binomial theorem. Till then, I hope to see you next.